Yeah, now in this video we're going to start looking at the parametric equations, okay, on our calculator. Now, one of the first things you have to do is go and set your mode, okay? Now, typically you have these mode types that the calculator can handle. Up to now, we've been locked in functions. We will look at parametric now, okay? Polar, we will look at later. And the remaining three, perhaps in the calculus, you will look at them. Okay, so we're going to set our mode to parametric, and we're going to set our degrees, our angle, to radians. Okay, you, of course, you can toggle between radian and degree. We're going to keep it at radian, right? Okay, now we're going to come in, we're going to plot our circle. Okay, this from here we'll follow this. It says let's go with the plotting the let's start by plotting x is 2 cosine of t, 2 cosine t, and y is 2 the sine of t. 2 the sine of t. And now, before you go anywhere, you want to go to your window. So I'm in window, and you want to. I'm gonna have to set these. Okay, the t minimum is going to go start at 0, and then we're going to kick it up to 2 pi. Okay, so 2 pi. Here's our pi value right here. Okay. The t step is going to be set at pi over 24. Okay, they're probably already in there, the default values. Okay, so you may not have to do it, but for future reference, you may have to. X minimum, X max is going to be set at -3 and +3 respectively, and +3. Okay. And I think we're good to go. Okay, so now we can graph, and we can graph our circle. And you say, that's not a circle, it's an ellipse. Well, okay, let's justify that. The screen resolution is not the same in X as it is in Y. You can see that this span is 3 units in X, but that length is not the same up here in Y. So you have to go to zoom to the square window, okay? Zoom to our square window to get a better view of that. Okay, so now let's see, let's do this again. Graph that, and you see that that's going to graph the same way as we did our unit circle. It's going to start in the positive x-axis and go counterclockwise. Okay, and so that should be of no surprise. Now if we altered this, okay, and you can, I mean, I'd just invite you to go and explore it a little bit, okay. If you altered this by, let's say, and you put a -2 sign, all right, okay, -2 sign of t. Let's see what do you think would happen. Well, okay, let's explore that. Okay. So what's going to happen is, okay, the first point it's going to plot is going to be, okay, in the lower quadrants. Let's justify that. Okay, there we go. We're actually, we changed the, or we did not change the circle. The end result is the same, but what we changed is the rotation. We're now rotating clockwise. Okay. We're now rotating clockwise as opposed to the other one in which we were rotating counterclockwise, the more traditional sense. So you have that's what makes the graphing in parametrics dynamic, because you can actually control not the end result's going to be the same, but how we get there is going to be a big difference. Now let's go and make some further alterations. If we change this here, and now go and make that coefficient 4. Okay, so now we've got 2 cosine and 4 sine. Now that should give us our graph of our ellipse. Okay, so let's take a look at that. That's the graph of the ellipse. Okay, and the major axis now is oriented in the y, and the minor axis is oriented in the x. And of course, we're not really seeing that whole thing because we have to come and change our y and minimum from -3 to at least -4, and likewise the y max. Okay, so now you'll see the entire graph, right? Okay, so there you have that. All right, let's come back to our 2 cosine, 2 sine, and let's play with the window now. I mean the t-step. So this is our graph of our circle of radius 2. No surprise in there. I might want to just come back and tweak that out by, again, zooming square. Okay. And I'll tell you what, I'm just going to make one slight change here. I'm going to make that circle of radius 3 just to get a better view of it. Okay. So just bear with me here. I'm going to put this in as 3. And we're going to try to do some fanciful changes here. Okay. So there we go. And now we got a circle of radius 3, right? Okay. So here's our circle of radius 3. Now, let's see what we have to do. Okay. I'm going to go to the window and I'm going to change my t-step. I'm going to change my t-step to be pi over 2 now. Okay, so that's going to be pi divided by 2. Okay. Now, I did not change my equations. So this should still come out to x squared plus y squared equals 9 when I eliminate my parameter. But look at what is graphed for us. What? Look at what is graphed. Yes, that's right. Because this is the control you have in parametrics with the t-step. Okay, we told this to plot every 90 degrees. So it is graphing our circle, but it's only plotting points every 90 degrees. Every 90 degrees, which means it's effectively plotting a square for us. Okay, so if I play with that t-step even more, if I said, what if I change that to, what if I change my t-step to pi over 3 now, okay, change the t-step to pi over 3, then I should be graphing, okay, a hexagon. Because I'm graphing every 60 degrees, okay? I'm graphing every 60 degrees. It's still the same functions that I'm graphing. So eliminating the parameter would still return to me a circle. But in terms of the point plotting, which is being controlled by the parametric equation mode, it's only plotting points every 120 degrees. So here it is. I'm sorry, every 60 degrees. So there it is, plotting every 60 degrees. Bam, 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 every 60 degrees. Now, I just say 120, so that's what I want to do next, is change that, change the t-step to 120. Well, not 120, but 2 pi over 3. 2 pi divided by 3. Okay, and the graph should be an equilateral triangle. There it is. And there's my equilateral triangle. All right, plotting every 120 degrees. Now, let's explore something else in the window. This we kicked up to the T max, the 2 pi. What should happen if I kick that up to 12 pi? Well, guess before you go forth and do it, but we're going to take a look right here. Nothing. But you notice that it's still busy. So in other words, it's still graphing points even after it's done. But the points are being graphed right back on top of each other because it's going every 120 degrees. It keeps plotting points right on top of each other. Now, I'm going to just show you something that's kind of neat. I'm going to change this t-step. That t-step is 2 pi over 3, which is, as you can see, decimal value there, 2.09. And let's look at what happens when I just change that to just 2. Get ready. Here it is. And you can see what I've done is I've staggered my triangles that are being plotted, okay, because they're not falling back on top of each other exactly. All right, and just for effect, we'll kick this up from 12 pi to let's say 20 pi. Let's see what happens. Okay. Are you ready? Here it goes. It's just going to keep graphing it. All right, and there we have it. Kind of neat geometric design. All right, brought to you by Parametric Equations. How do you like that?